Hello, this is Mrs. Taylor, and I am going to go over how to tell if a limit exists. So how do you even know if a limit exists? And in this situation, we're going to focus more on where the limit does not exist, because that's more what we're concerned about when we're asking about the existence of a limit. And there are three cases where a limit does not exist. The first case is if the curve approaches a different y value from the left and the right. So the two pieces of the curve don't meet at the same y value. The second case is if we have unbounded behavior, so our curve curves upward and approaches positive infinity, or curves downward and approaches negative infinity. So it just kind of shoots up or down without bound. And then the last case is when we have oscillating behavior. Oscillate means to move back and forth between two values. An example would be a sine curve that bounces between 1 and -1. But a sine curve has a limit. These cases are graphs that bounce back and forth repeatedly, much more closely together. And we'll look at some examples of those graphs. Where you might have seen the word oscillating before is oscillating fans that you buy at the store. They're the kind that move left and right. That's what oscillating means. So let's look at some graphs of these three cases. The first graph here in the top left corner is a case where our curve does not approach the same y value from the left and from the right. So we would say the limit does not exist at x equals 3. Because as it approaches from the left, it's approaching 1, and as it's approaching from the right, it's approaching 4. So when we talk about a limit not existing, we talk about it not existing at an x value. And so in this case, the limit would not exist at x equals 3. In this graph, this is an example of unbounded behavior. So from the left, the curve curves infinitely downward, which would be towards negative infinity, and from the right it curves infinitely upward, which would be approaching positive infinity. So this function in particular, the limit does not exist at x sub 0, whatever this x value is. And then this bottom left graph, this is an example of oscillating behavior. So if you notice, it is bouncing back and forth, but when it gets to x equals 1, it's really bouncing up and down uncontrollably. So that would be an example of oscillating behavior, where the closer you get to an x value, it just bounces up and down really rapidly. And so you would say the limit does not exist for this function at x equals 1. So what we're going to do is we're going to focus on some very special functions that you just need to be familiar with and recognize them. They can lead to really quick, correct answers on quizzes or tests or your AP exam. And also I'm going to introduce some tools while we're doing this. So first, let's look at the limit as x approaches 0 of the absolute value of x over x. This is a very popular problem when it comes to AP Calculus with the exam and practice problems, so it's really good to start recognizing it. And so it also gives us an opportunity to review how to find absolute value in our calculator. So what we're going to do is we're going to graph the absolute value of x over x in our calculator and determine to show that the limit does not exist. So if you use your graphing calculator, what you want to do is you want to first enter our function into the y equals menu. So press y equals. And remember, when you have a rational, you want to put everything that's in your numerator in parentheses, and then everything that's in your denominator in parentheses. So we'll start with parentheses. And to get to absolute value, you go to the math menu. So math is here. Go over to the number menu, and option number 1 is your absolute value. It gives you the absolute value bars if you have the math print program on your calculator. If not, it'll say abs and then parentheses. So you just put X, and then if you have the older calculators, you just put a second parentheses, and then if not, you just move your cursor out of the absolute value bars, finish off your numerator parentheses, and then divided by. And since it's just X for this function, we can just press X. We don't really have to put it in its own set of parentheses. And if I press graph, I get something that looks like this. And what's happening here is as X is approaching 0, which is our X value we're focusing in on, as X approaches 0, from the left, my Y value is -1, but from the right, my Y value is +1. So this is a case where the limit does not exist because my function is approaching two different Y values at X equals 0. And so the way I would write that as an answer would be equals, and then I just put DNE for does not exist. You have to forgive my handwriting. I'm writing with the mouse. And so if it asked me to justify my answer, what I would say is because the function does not approach the same Y value from the left and from the right. And then also if I wanted to, I could provide the graph, a sketch of the graph as well. I just want to take this opportunity to also discuss the importance of what X is approaching, because if this question had asked the limit of this function as X approaches, let's say, -1, if you look at the graph, as X is approaching -1, my Y values are the same from the left and from the right. So if the question was, instead of X approaches 0, X approaches -1, my limit would exist. And I would say that it equals -1. And so that's a really important distinction when you're looking at these problems, is to pay attention to what the X is approaching. So let's look at another case. This one says, discuss the existence of the limit. The limit is X approaches 0 of 1 over X squared. And so this one just says discuss the existence of the limit. So really they're just asking you to determine if it actually exists as X approaches 0. So if I just type 1 divided by X squared into my calculator in the Y equals, clear out what's there, 1 divided by X squared, and press graph, this is what I have. And so we want to make sure that we see plenty of the functions. So if I go to zoom, I can do the standard zoom, which is just -10 to 10 by pressing 6. And it looks like what's happening as X approaches 0 is it's continuing infinitely upward, so approaching positive infinity from the left and from the right. And so this would be a case where my limit does not exist because of unbounded behavior. So does not exist. And then our last case that we're going to look at here is discuss the existence of the limit as X approaches 0 of sine of 1 divided by X. If I use my calculator for this one, it would look like this. So 1 divided by X. Oops, I forgot the sign. So sine of 1 divided by X. Graph. I get something that looks like this. It's really hard to see, really hard to read if I change to the trig window. And one thing to note, in AP Calculus, we are only working in radians, so make sure that your mode is in radian mode. But if I go to zoom and choose the trig window, which is 7, the graph looks a little bit better, but it's really hard to see what's going on there. So I wanted to take this opportunity to introduce WinPlot. It's a free program that you can get online that is designed for you to graph functions. You can do all types of different plots with this program, but sometimes visually you can get a better idea of the graph's behavior using a computer program instead of your graphing calculator. If you do a quick internet search of WinPlot, it'll bring up a page where you can download it for free, which I have already done. So if I just open WinPlot on my computer, it looks something like this. And it's really not anything extravagant, but if you go to Window and we want to plot in 2 dimensions, and I want to enter an equation, so I go to the Equa menu, and it is an explicit, which means it's in the form y equals, and then whatever my function. And so my function here is sine of 1 divided by x, so I type in sine of 1 divided by x, and then I hit OK. And so what I have here is something a little more clear than what is on the calculator screen. However, I can zoom in and zoom out to get a clearer idea of what the graph looks like. So the way I would do that is I would go to View, Zoom, I can zoom in. I can do that over and over again. But as you can see, there's shortcuts here, page up, page down. So if I just hit page up several times, I can see a little bit more clearly what's happening with this graph as opposed to your calculator view, which is not great. So just using this as an opportunity to introduce you to some other graphing software besides your calculator that may be available out there. There are other graphing apps on your phones, on your tablets, on your computer. Do a quick internet search and you'll get tons of graphing programs that are visually better than your calculator. Either way, it's clear that this is a case where we have an oscillating graph at x equals 0, and that is what x is approaching in this case, so we would say that this limit does not exist as well. And again, messy handwriting, I'm using the mouse. So bottom line is when we are asked to discuss the existence of a limit, really what they're asking is, does the limit exist or not at that x value? And remember that you can discuss the limit at any x value. It just doesn't have to be the one x value where a graph has some funky behavior going on. So just keep that in mind when you're given a bunch of problems to pay attention to that x value. And that's how you determine the existence of a limit.